Software tool is developed for different parts of the research, and in order to use it, we begin by simply executing a single line of code that launches the main interface. You will see different tools listed here, each developed for different applications. There are also descriptions provided for each tool once it is selected. Let's start with the first tool at the top, which is designed for strings prediction and the multi-objective optimization of UHPC mixture. Once we select it and press the Run button, a new interface for this tool will appear. This first tool offers three main options, as you can see. First, imagine a project requires UHPC with a specific compressed strings, say 170 megapascal. By selecting the first option and entering the desired compressed strings, which is 170 in this case, and hit OK button, the software calculates the optimal economical and environmentally sustainable UHPC mixture to achieve these strings. Additionally, it provides the cost of this mix in USD along with the 17 critical environmental impact metrics. The second option enables us to assign weight to the 19 objective functions based on specific project requirements and determine the optimal sustainable UHPC mixture. This is done by resetting the software with the reset button and selecting option 2. Now we need to enter the weight for each objective functions separated by commas. For demonstration purpose, let's assume equal weights for all. Upon providing the weights, this tool suggests an optimized UHPC mixture that balances cost, environmental sustainability, and the strings. This optimized mixture has compressed strings of 174 megapascal. Like the first option, the tool also shows the cost and environmental impact matrix for this mixture. There might be times when we already have a UHPC mixture in hand and we need to know the compressed strings of this mixture. So instead of going to the lab and conducting the test, we can use the third option to estimate the strings. Simply select the third option and then input values of the input features separated by comma. The tool will then provide the predicted compressed strings of this UHPC mixture. Let's return to the main interface and select the second tool. This tool is designed to predict the peak and ultimate stress strain response of confined UHPC. In order to activate this tool, we simply press the Run button. With that done, we will be greeted by a new interface ready for our input. Imagine we are dealing with a circular UHPC column reinforced with transverse bars having reinforcement ratio of 0.034 and a yield strength of 380 megapascal. Assume effective confinement at 0.86 and the UHPC's compressed strength of 211 megapascal with a volumetric fiber ratio of 0.38. We can then proceed to click the Predict button and the tool then provides the predicted peak and ultimate stress strain response of this confined UHPC. Let's close this and then navigate back to the main interface in order to explore the third tool. This tool is specifically designed for accurately predicting the complete stress strain response of UHPC confined with either normal strain steel or high strain steel spirals. We can press the Run button and activate this third tool, which opens a new interface for this tool. We can now define the values of the input parameters, considering the range of applications of the tool presented on the right side of each parameter. Once the values of all input parameters are defined, we can hit the Predict and the Plot button in order to visualize the full stress strain response curve for the confined UHPC, along with a summary of the parameter we define. Additionally, there is an option to export the stress strain response data into Excel. Let's close this and return to the main interface in order to demonstrate the force tool. This force tool is used for predicting the drift demand across 4 different damage states. Once we activate it by clicking on the Run button, we will be taken to a new interface. Again, we need to define the values of the input parameters and click the Predict button. The tool then calculates and displays the predicted drift ratios for all damage states, as you can see here.